The accent's a bit funny because I come from Northern Ireland, but good golfers come from. And I've been in the States since 1974. Spent the first 12 years working on oil shale and stuff. But, anyway, this is a little piece of oil shale. This is what you normally see when you're looking at the mountains all the way up to Rifle and over there by Douglas Pass and so on. You just see the outside. It looks. But once you chip at the inside, then you can see where the oil is, and you can see the layers of oil that is in the rock. And right, we'll sort of get going here. They sort of figured out that how they discovered oil shale in this part of the world was simply some poor old rancher built his log cabin, and then he made the fireplace out of oil shale. And as soon as he lit the fire, the whole cabin burned down. But it does burn pretty easily. This is just a bit of the history. It got going a long time ago, back in the 1800s, and Scotland did a tremendous lot with the oil shale. They had they built the big metal retorts where they cooked the stuff, and then they ran out of shale. They imported some from Australia, and finally sent their retorts down to Australia. Things got going fairly well in the States at the early part of last century, and by 1960 you had 50 companies producing shale oil in the US and Canada in small amounts, not really a commercial business or anything like that, but in fact some of the early shale oil was just used as horse liniment. As you can see, this gives you an idea of just how important it is. The world oil shale reserves are 2.6 trillion barrels, and we've got at least 1.8 trillion barrels in the Green River Formation. That's Colorado, Utah, and Wyoming. And so the majority of the oil shale in the world is in the States and in this area, which shows you just how important it is to get going. And just put in here that the US uses about 20 million barrels a day of oil, of which probably half is imported, maybe more than half nowadays. It used to be half in the old days, but I think it's even worse nowadays. With different types of methods of extracting the shale oil, above ground retorts, true in situ, modified in situ, and a little bit of solvent extraction. And I'll cover some of these, some in more detail than others. Important in this area, we had the Parahoe retort. That was between Parachute and Rifle. If you're driving up there, there's a road that just heads off into the mountains, and Parahoe was up there. The road leading up to their retorting system was actually made from asphalt from oil shale, and it's been there for 50 or 60 years now, and there's not a crack in it. So important stuff. Union B, I'll go into details on that. That was a above ground retort that was heated, the shale was heated with external heated gases. Tosco 2, it was heated by circulation of externally heated solids. And Kerr's factory here in town, the ceramic factory, they essentially came here to make these ceramic balls that were going to be used in the Tosco process. The Tosco process was bought over from, Tosco means the oil shale company, and it was bought over by Exxon. And they finally give up the ghost in 1982 or so. Some true in situ process, Shell Oil, Sinclair Oil, Geokinetics, and Exxon Mobil. Exxon are now experimenting with true in situ right now. Shell Oil, they drill holes in the ground, drop down electric resistance heaters and heat the shale down there. I'll mention a bit more about that later. Exxon, they're horizontally drilled, big mine into the mountain, and then the horizontally drilled holes that they fill with conductive material, electrically conductive material that heats up and it fractures the rock, and try to get it all out that way. And they're right now they're experimenting with that. Everything's still going on. Modified in situ, that just means instead of just doing all your work on the shale underground and not disturbing the ground, they modified in situ do a certain amount of mining as well as doing all your retorting underground. And Oxy was the firm that I came to work for. They recruited me from Saudi Arabia. I was working out there, and they asked me if I'd come and work in Rifle, Colorado, and I didn't know what Rifle was or where it was, and I didn't know what oil shale was. But anything to come to the States I thought was pretty good, so I took them on. The Rio Blanco oil shale project, they used the Oxy process, and they did some, about 3 retorts up in the Piceance Basin. Solvent extraction projects, Chevron are playing around with that right now in their research facility. They would pulverize the shale, and they would use critical carbon dioxide mixture that supercritical, liquefied, and try and extract the shale that way. They're also down in Australia. They're playing around there with different solvents like benzene and acetone and so on, which obviously has a certain amount of potential. The difficulties are once you've dissolved the oil in the solvent, then you have to get the oil out of the solvent, and that can create some problems. The Oxy process is the one I'll spend a bit of time on. This is our site up at the back. It was going to be our commercial site, and then we discovered that we could get involved with one of the sites up in Piceance Basin that had much richer shale. The shale on this site averaged 15 gallons per ton of rock. The Piceance Basin shale that we were looking at was 40 gallons per ton of rock, so I reckon we could make more money out of that one. We have 2 mine benches, one here, and then we mined 2 adits at each level so that you would have air circulating through, and built our retorts underground. There, up on the surface, is where we had our off-gas facilities. Essentially, the blowers sat up there that actually sucked gas from the bottom of the retorts. We had a stack. In those days, we got permission to just vent our off-gases without having to totally clean them, because it was such a small operation and it was an experimental thing. The oil that we produced went by pipeline down the side of the mountain. This is essentially spoils that have been emptied out of the mine, and then down below here we have a heater-treater system to help separate the last bits of processed water out of the oil, and then we would ship it off by truck just from there. Here's essentially how we do it all. We go into the mine, and we will create, we mine out rooms, and these rooms create the void so that when you blast the rock, it's got somewhere to move. So 25% of the area taken up by a retort is going to be mined out. And so we mine these rooms, then we drill holes at 6 or 8 inches right the whole way through the retort, and fill these with explosive, about 500,000 pounds of explosive, and we set off in one big bang and scare the heck out of everybody in Quebec, of course, because cold ground shakes. The explosive is just ammonium nitrate, fertilizer, mixed with diesel fuel. I'm not sure if the Arabs didn't catch on to that, and that's why they're using fertilizer all the time for their bombs. But anyway, and then we're just demonstrating there the rubblized retort. And we build bulkheads into the retort and across here so that we can run the retort under negative pressure. If there's any leaks, they're always inwards. And also it keeps us from setting fire to the mine, because the whole mountain's made of burnable rock. And one of our retorts, this level here actually collapsed. The fire got out, got up the, no, I mean we set fire. We had a little volcano for a little while. It took us quite a while to get control of it again, but anyway, I can talk about that for hours, so I'll stay off it. Okay, so we have air and steam coming in. You need a mixture of air and steam, because if you have just straight air, then your rock will all burn and you'll burn all your oil, and that'll be the end of that. So you try and keep your flame front as it burns down through here at a controlled temperature, and it drives the oil out of the rock. It leaves a carbon residue behind, and that carbon is what then keeps burning the whole way down to the bottom, and the oil condenses at the bottom. For every barrel of oil you make a barrel of water, and the oil and water is taken off. The off gas then is taken up to the surface of the mine. This is just another demonstration in colours. This is our whole commercial process as we had it. We've shown the retort being constructed, and the rock is taken out. We would then pulverize it, send it into a fluidized bed boiler, and make steam with it, and drive a turbine and export electricity. Now, if you've read the newspapers, they all say, you know, the oil shale industry is going to have to build power stations to make electricity. We export electricity. The off gases coming off the retort, they'll have some light hydrocarbons in there that are condensed, and actually we were able to run a diesel engine straight from the retort without any cleanup, although in reality you would do some stabilization. Any other off gases, which are pretty low BTU, they're fed into the same boiler that into another little low BTU boiler, and it makes some more steam and makes electricity. The raw shale and oil comes out the bottom. You separate it off the water. You can also separate some high nitrogen compounds that are quite valuable. You upgrade your oil and you send it to a refinery. I'll cover the upgrading a little bit later. And we made jet fuel and gasoline and all sorts of things out of our oil. In all the Occidental process, we made about 300,000 barrels of oil. I didn't know you'd put this picture in. That's my grandson. Okay, I'm just going to go on with it. The Union Oil process, it ran from 1980 to 1981, and as you can see there, they produced 4.5 million barrels. They've got a grant from the Synthetic Fuels Corporation, and they could sell their oil for $48 a barrel, which certainly, you know, they were making a little profit at that time on $48 a barrel. But that's back in the 1980s. Nowadays, you'd need about twice that or so. This is just how they mined it. They rim and pillar. They would mine into the area. They'd have to leave these pillars so that the roof wouldn't collapse. Shale is very nice to work with because you get most of the time nice flat ceilings because it comes off as flat rock, and then they had plans afterwards to maybe get some of these pillars out, or even there is some consideration of drilling down and creating a modified in situ process as well. Mechanical engineers would really love this. This is a carriage that they load up with rock. It passes underneath, this is the retort here. this piston comes up and pushes the rock into the retort. As it comes down, the carriage will be empty. It moves over, and another loaded one then will take its place, and just backwards and forwards is how they fill the containers and get the retort filled. So the shale is constantly sort of pumped into the retort. By the time it gets to the top, it's totally retorted. It's essentially a white powder is what you get at the top. And this is a big mechanical arm here that just goes round and round, and it scrapes the shale off, the spent shale, and it pops down here and ends up being taken off to a spent shale pile or repository on the site. One of the difficulties was the shale is so powdery and fine that hot gases rising up here would stop the shale falling, and they had all sorts of plug-in. And this mechanical arm broke several times, and had lots of fun and games, trying to get it to work right. But eventually, as I say, it made 4.5 million barrels of oil. The gases that are taken off, they're then sent back in to heat the shale. The oil itself is then your crude oil is pumped off to an upgrading facility. The kerosene molecule, that's the black stuff you see in the rock there. That's a large, complicated complex, as they call it, molecule, which is loosely bound carbon, hydrogen, oxygen, a small amount of nitrogen, and a small amount of sulfur. And this is just a diagram of the molecule. As you can see, there's all sorts of benzene molecules in there, so that as well as just benzene, you've got compounds in there that are also carcinogenic, and some of them are water soluble. So you've got to be, you've got to treat the oil very carefully, and that's one of the difficulties with the in situ process, because you're in contact with the groundwater there. The products, this is what the environmentalists will get excited about: shale oil off gas, processed water, and spent shale. The shale oil itself is pretty much like a regular crude, only it's got a fairly high nitrogen content. And that nitrogen content means that you have a lot of difficulty running it in a regular refinery. So it has to be upgraded before it's sent there. As I said, there's some carcinogenic water-soluble compounds. It's essentially non-Newtonian in so much that the viscosity doesn't decrease as the temperature goes up. If you run your car too hot, your oil gets very thin, but this oil would get very thick. And it forms very viscous emulsions with the water if you just use regular pumping, pumps like centrifugal pumps and so on. There's too much shear involved there, so that you start pumping and you watch your pressure gauge, and it just rises till it's up to, heck, it could be 3,000 psi, in the discharge of your pumps, if you pump it do that much. So we hunted around for pumps that would work for it, and we came up with a low shear pump, which was essentially the firm that made them in those days was called Moino, and it's a screw pump. I think the technical term for the pump is a progressive cavity pump, and it just adds this energy to the oil as it pushes it through without a lot of physical action against the oil and the oil-water mixture, and it worked pretty well. We had to, the screw itself was stainless steel because your oil and water is pretty corrosive, and there was a liner around the screw pump, and we used Viton. Now this is stuff you never get anywhere else, guys. We came up with this, and an awful lot of the notes on oil and the oxy process have been lost. And so if you ever get involved in it, you have to trying to remember. This is how you pump this stuff and whatnot. Regular rubber will if you made a liner, like in a pond, and keep your oil in it, the regular rubber will just dissolve in it. So we have to use, as I say, various other synthetic rubbers and so on to do the trick. Let's see, what was it? The upgrading process, what we do there is the raw oil is sent to a unit cracking unit where the oil is subjected to high pressures and temperatures in a hydrogen atmosphere in the presence of a catalyst. What you're trying to do is to get the hydrogen to react with the sulfur and the nitrogen that are in the oil, and they will essentially be converted to ammonia and sulfur dioxide, well, hydrogen sulfide, and eventually to sulfur dioxide, and you can make sulfuric acid out of it. The plant I worked out in Saudi Arabia, it was ammonia urea plant. We made ammonia, reacted it with carbon dioxide, and made urea fertilizer. So here is a little method of getting rid of some of the carbon dioxide, the greenhouse gases, if anybody was interested in it, and making something valuable at the same time. The off gases, again, environmentalists were really interested in what we were sending out into the atmosphere. All of these compounds, the methane, of course, can be burnt, and the hydrogen sulfide and sulfur dioxide can be extracted pretty easily, along with the mercaptans. The ammonia can be trapped, and the nitrogen oxides, they're pretty hard to get rid of, but it can be done. And carbon monoxide, of course, is a combustible, so it'll combust along with the hydrocarbon gases. And of course, we get pipes run all through the mine carrying these gases. Hydrogen sulfide in particular is extremely dangerous, so you have to be pretty careful that you don't have any leaks on your piping systems and so on. And that could be, because your pipes are going all over the mine, you've got expansion problems, and you have to be pretty careful in how you choose your expansion joints and whatnot. The off gases themselves are pretty low BTU, but they can be heated or burnt all right, and the heat recovered. The processed water coming off the retort, the off gases, when they cool down, you condense out some light organics that we could use for diesel fuel, and we would have to separate off any free oil that was condensed out, and then any organics that were remaining in the oil. We did some experiments with bugs where we got rid of most of the oil there, and then finally just had an activated carbon treatment to clean up the water, and it would have been drinkable at that stage. And of course, the Daily Sentinel say all of the oil shale processes are going to use every bit of water that's in the Colorado River, but not quite. We can export water to you from this process. The water coming off the bottom of the retort is a different matter. It hasn't been distilled or anything, so it's condensed out there, and it's got minerals in it and organics. You can spray it on the ground for dust control, or it can be treated by essentially, once you've got the free oil, you just use an API separator, which is an inclined plate, and the oil hits that, the oil water mixture hits that, the oil comes to the surface, and the water goes straight on through. And we ran these things that are called thermal sludge boilers. I don't know if you can still buy them nowadays, but we had two of them on the site, in fact, and they would take this processed water and generate steam out of it. And the big difficulty when you're trying to make steam from bad water is your tubes get so hot in the furnace of the boiler that they just cake on the furnace tubes, and they eventually then expand and burst. So what we did there was, instead of heating or generating steam using the flame in the boiler, we heated in the boiler. We heated this salt, molten salt, and then we generated the steam in the heat exchanger with the molten salt on one side and the processed water on the other. And it was highly successful. Worked very well. You had maybe as much as 25% blowdown, so you're still left with some that you have to treat in the end. But at the same time, they were pretty successful. The other product that comes out of the retorts is the spent shale, and normally those are put in a lined repository on the site. Collect any drainage liquids that would come down to the bottom, and they would have to be treated like we did with the regular processed water. The spent shale, we did a lot of experiments on that, see if we could revegetate it, and it worked. There wasn't any problem at all. Like the union process, where you've got all your organics out of the shale, they can then, that white powder that I was talking about can be used to make cement. And raw shale can be, before it's retorted, can be used to make cement too. And there's a couple of guys in town here trying to experiment with that. Current projects that are operating, Shale Oil, as I say, they've been playing around with their in situ process. Because you're making this material down there that's carcinogenic and whatnot, you've got to make sure that you don't pollute your groundwater. And they're experimenting with, or have been experimenting with a freeze wall, where they do, instead of putting heat down into the ground, they're putting refrigerant down in there and freezing these huge areas. I don't know how thick they are, 6 feet or something like that, all around your retorted area, trying to contain the groundwater that's in there, and then they can pump the groundwater up and treat. Seems to me you'd have to keep your freeze wall going for eternity, so I'm not sure it's a great idea. But they are now, they've stopped the present process and are now playing around with trying to drill. Instead of being down a couple of thousand feet for this, they go down to about 3,000 or 4,000 feet, where there's not any groundwater, and if there was any, it's pretty bad quality. So anyway, that's them. The Oil Shale Exploration Company is another project that was going, that's just recently been bought over by Estonia, the country of Estonia. They've come in and they're they've moved into Utah, and they're going to run above ground retorts out on it's the old I think it's the old Utah B site, and they hope to get a process going up there, producing 57,000 barrels a day of shale oil. And there are a few other projects around. Sage Geotech, American Shale Oil Company. They got involved with Schlumberger, and they're trying to do a microwave process. If you don't have oil, this is what we're stuck with. This is an old jaunting cart in Ireland, actually. Or on my sailboat, we don't need oil out there. Lastly, this is the commercial site that we took over up in the Piance Basin, halfway between Rifle and Meeker. These are the head frames that we built. We sunk shafts down. This was a 29-foot diameter shaft, went down 2,000 feet approx. And this was the service shaft that would bring the men and equipment down. The big drill rigs that had to, horizontal drill rigs that would drive the drifts. They came up and down there, and they had something like 8,000 horsepower hoists up here that would bring the skips up and down in the production shaft. Then when we shut down the whole process in about 1986 or so, that was when I finally lost my job, because there's nothing there left. But we kept the site open for a while. We were making 450 barrels of 450 gallons a minute of groundwater that we're having to pump to keep the shafts dry. Again, we were exporting water, and it was getting expensive. Oxford spent a couple of million a year, and they asked for permission to shut down the pumps and let it rise up. And then the BLM came in and said, you've got to knock these head frames down, mine reclamation and all that sort of thing. So they knocked these down. This is 308 feet high. It's a huge thing. And they essentially collapsed a lot of them into trenches, or a lot of it must have gone down the shafts as well. And that was $350 million down the drain. That's what it cost us to get to this point on this site. And then about 5 years later, they came along and said, hey, anybody interested in having an oil shale plant out here? So that's what happens. But anyway, this is the pot of gold at the end of the rainbow. And I hope someday we can get it going again. And I tell you this much, they'll need more engineers than this country can produce to run an oil shale industry. So the jobs for everybody. If anybody's got any question, I'll work.
So what about the pipeline that's being talked about from Canada down to Texas? Is that oil shale from Canada going to be piped?
That's tar sands from Canada. Tar sands are a lot easier to work than the oil shale. It's a softer material, and all you need is hot water essentially to get the tar sands brought up to the surface, and then they separate off the oil and the water. And I mean, it's a big problem because they get huge lakes of polluted water up in Canada, but they want to sell us the oil. And certainly, the oil shale itself would need to. Best thing to do is to pipe it off to a refinery somewhere, or build a refinery. There used to be a refinery in town here that actually could take shale oil without upgrading it. It was just, I don't know if you've ever seen it or smelt it on the way out to Fritta. It's the old Gary Western Gilsonite refinery. Gilsonite's another shale type compound that was in this area that was quite commercial at one point.
What price of oil per barrel does it need to justify to be recovering oil shale today in today's dollars?
Yeah, I would personally, I think, and if I wanted to get an oil shale industry going, and I was the government, I would say, okay, we'd guarantee you $100 a barrel, and they could make money of that. And that's the difficulty. You're $100 a barrel one day and $70 a barrel the next, and it's just all over the place. It's pretty difficult. When we were getting going with the oil shale, and there was a lot of companies interested in it, the Saudis dropped the price of oil and left us. We couldn't keep the process going. I mean, we couldn't afford to sell our oil.
Is the U.S. Department of Energy no longer involved in any of the oil shale?
Good question. Morgantown, which belongs to the U.S. Energy Department out there, and they may be still messing around with some experimenting and stuff. The oil shale office that we worked with when we were building this site and so on, they were under the Department of Energy. But then when the Synthetic Fuels Corporation died to death, President Reagan didn't think that we needed oil or solar energy, since you take all the solar panels off the White House.
Right.
You mentioned there's this oil produces a sour oil compared to the sweet. Could you elaborate a little bit on this? Is it a dirtier oil, a sour oil than a sweet, or is it sulfur?
When you talk about sweet oil, that's oil that doesn't have a lot of sulfur compounds in it, and and it's called sour because it smells sour, and the sulfur and the hydrogen sulfide and captains. Well, captains are what they normally would put in a domestic gas line so that you can smell the gas at your stove in case you leave it turned on. Those are just a tiny little bit of captains. They stink something awful. So that's pretty much how you put
So the sour then is harder to refine, or it produces more byproducts that are undesirable?
Because of its nature and all the nitrogen and sulfur compounds in there, it tends to clog up the refinery. So that's why we had to do the upgrading process and react it with hydrogen to get rid of those other compounds. And the asphalt that's left behind, then it can be used for road building and so on. And because of the nitrogen compounds that are in the asphalt, that nitrogen will form a chemical bond with the aggregate so that you get a much better asphalt. And I was involved with run some experiments up at Wyoming University on the oil shale, where we would take what looked a bit like the valve in an engine. You know, it's the stem and then it sloped sides, and we'd make a little briquette of shale oil. That's the oil, the asphalt mixed with the aggregate, and drop that on top of that, and then we'd do freeze-thaw cycles. Ordinary, you know, put it in the fridge for 12 hours, take it out for 12 hours, back in, and so on. And ordinary crude, you got about 5 or 6 freeze-thaw cycles, and then that asphalt would show a crack. And the shale oil, the oxy shale oil, we got 50, 60. The power hose shale oil was over 100. And they took some of that power hose project shale oil, and they built, I think it was 3 test sections of road outside Rifle, and I guess they're still watching them to see how they're doing. Because they reckoned, hey, if we can sell our asphalt for even more than we get for oil, then it's going to help us. The other thing that some friends of mine have been working on, and that is looking at the minerals that are in the shale. When you're retorting the shale, you're going to have materials that you can then easier extract minerals out of it. You're already mined it and whatnot, and some of the compounds in there are chromium, cobalt, gallium, lithium, which is very precious, manganese, molybdenum. There's magnesium in there too, and you know, if you can, whatever you can do to make your product more valuable,
Any other questions?
Thanks for your attention, folks.
Thank you.